Assalamu alaikum dear students. How are you all? Hope you will be fine and enjoying good health. And let's start our today's lecture, which is related to Unit 5, Physical States of Matter, and topic allotropy. The phenomena of an element existing in two or more physical forms is what is allotropy. For example, the property of some chemical elements to exist in two or more different forms known as allotropes of these elements. For example, different structural modification of an element. For example, carbon exists in the two forms. And one thing you should know clearly, that only element exist in the different combination. Element exist in the different combination of atoms, but they have different physical properties, but their chemical properties are same. They exist only in different physical forms and colors and structure arrangement. So existence of one element into different form or structures, structure arrangement is called allotropy. The existence of element into more than one forms in same physical state is called allotropy. Allotropy is due to existence of two or more kinds of molecules of an element, each having different number of atoms, such as allotropes of oxygen or O2 and O3 ozone. Listen guys, you can see here that existence of two or more kinds of molecules of an element. For example, when the atoms of an element, two atoms of the element of oxygen will combine, they will form oxygen, and when three atoms of an element of oxygen will combine, they will form ozone. Now oxygen have the same properties, they have same chemical properties, but the existence of the oxygen into two forms is called its allotropic form. Different arrangement of two or more atoms or molecules in a crystal of the element, such as sulfur, shows allotropy due to arrangement of molecules in the crystals. There are the two main reasons and two main form of allotropy. In the first type, in which the atoms of an element combine to form different molecule, for example O2 or O3. But second type, in the second form of allotropy, is the arrangement of atoms, two or more atoms or molecules in a crystal of the element, such as sulfur shows allotropy due to different arrangement of molecules in the crystals. They always show different physical properties but have same chemical properties. They have different physical properties due to structural arrangement, but they have same chemical properties. And an allotrope is a different form of the same element. So for example, diamond and graphite are both allotropes of carbon. So carbon can exist in the two forms, diamond and graphite. Allotropes of solids have different arrangement of atoms in space at a given temperature. For example, we have studied two type of allotropic forms, in which the combination of atoms to form different molecule, for example O2 or O3, and second one was the structural arrangement at different temperature. And here it will discuss about sulfur and phosphorus, rhombic and monoclinic form. And the temperature, if we heat the S8, the structure will be rhombic, and when it will change into at the 96 degrees Celsius, it will change into S8. Its mean sulfur 8 exists in two structural arrangements. First structure arrangement is rhombic below 96, and above 96 it will be changed into S8 monoclinic structure. So the temperature at which one shape and one structure of molecule will change into the other structure of the molecule in crystal lattice, it will called transition temperature. What is transition temperature? The temperature at which one allotrop changes into the another is called transition temperature. For example, transition temperature of sulfur is 96. Below this temperature, rhombic form is stable. If rhombic form is heated above 96, its molecules arrange themselves to form monoclinic form. You can see here that this is the rhombic shape and this is the monoclinic shape. When we heat the sulfur at 96 degrees Celsius, it will change into monoclinic, and below the 96 temperature it will remain in rhombic form, and this is called the temperature 96 temperature will be called transition temperature. Next, sulfur, phosphorus, another example of allotropic form of phosphorus, in which black phosphorus have different structure or red phosphorus have different structure, in which white we have to discuss the structure of white and red phosphorus. So there is the structure of black phosphorus and red phosphorus. You can also see the same difference will be present between red and white phosphorus. Next, another example, tin gray cubic structure, and when we heat it at 13.2 degrees Celsius, it will change into tetragonal shape. White phosphorus is very reactive, wasness and waxy solid. It exists as tetraatomic molecules, and while red phosphorus is less reactive, non-poisonous and a brittle powder. So you can see here is the structure of white phosphorus and gray phosphorus, and white phosphorus have body centered tetragonal crystal, that is, and gray tin have cubic structure, diamond cubic crystal structure like diamond. So next there will be MCQs, and we will discuss them in our online class. Till then, Allah Hafiz. Have a good day.